Okay, so we've got our homomorphism, and we know that alpha of xy equals alpha of x, alpha of y, where we've got to remember that that's the group operation in G, and this is the group operation in H. So what I'm going to work out is what alpha of E is equal to. So what does the map alpha send E to? Now, I'm going to be painfully explicit here. This E must be the identity element of the group G, because if it's in brackets and alpha operates on it, alpha operates on elements of G, not H. So we've got to be clear about that. So what is the definition of EG? Well, we know that XEG equals X for all X in group G. So if I ask what alpha of X is equal to, that's equal to alpha of X EG, which equals alpha of X, alpha of EG. And you'll remember that this thing here was what we're trying to find out. And of course, we've got this to remember, that these guys here, I'm just going to sort of draw sort of brackets around them. These guys in the brackets here, these square brackets here, are members of H, because alpha of X is a member of H. Now what I can do is multiply on the left by alpha of X to the minus 1. And of course, this minus 1 here is the inverse operation in group H. Alpha of X equals alpha of X minus 1, alpha of X, alpha of EG. So of course, this guy here is equal by definition to EH, because this thing here is a member of H. And look, I'm multiplying it by on the left at least, by its own inverse. And so by definition, it's the neutral, the identity element, equals the identity element in H by the same line of argument times alpha EG. And so that tells me, by multiplying on the left by EH to minus 1, which is kind of obvious, that alpha EG equals EH. That's nice. So alpha, if alpha is a homomorphism, it sends the identity to the identity. Well, it ought to do, really. That's what you see in the textbooks. That's what I saw in my lecture notes. But what I really mean is alpha of EG equals EH. So yes, it sends the identity to the identity, but what you really mean is it sends the identity of group G to the identity of group H. You need to keep in mind what is being mapped to what here. So there's the first property of homomorphism, and I'm going to stop there.